In today's video, we will start with the question 7. So the table below shows the cumulative frequencies for the annual income of 200 households in a certain district. The first column shows the annual incomes in thousands and the second column shows the respective cumulative frequencies. So in the part 1, we have to construct a frequency table from the given data. So here we are provided with the cumulative frequency table.
So from the cumulative frequency table, we have to construct the frequency table. First, we identify the class interval from the cumulative frequency table. Here the class intervals will be look like. The first class interval is from 0 to 20. Now the next one is from 20 to 40. The next one is from 40 to 60. How we came to know that upper limit are going to be only less than type. Since the cumulative frequency table is of less than type, so that's why we are taking the limits like 20 less than equals to x less than 40, not less than equals to 40. Now for the fourth class interval, we have 60 to 80. For the other class interval, we have 80 to 110. Now we have the last class interval from 110 to 120. For each class interval, we have to subtract the cumulative frequency of the previous interval from the current interval's cumulative frequency. And this is the frequency for the specific class interval. So, construct a new frequency table with the same class intervals and frequency column. Calculated differences from the cumulative frequencies. The first entry in the frequency column is always equals to the first cumulative frequency value. So here we have the first value 42. So we will copy it into the frequency table as it is. So here we have 42 as a first value.
Now to find the frequency for the class interval from 20 to 40, we have to subtract the cumulative frequency of the previous class interval, and that is 0 to 20.
And that is 0 to 20 from the class interval 20 to 40. So here we have the cumulative frequency of 80. We will do 80 minus 42 and it will give us the frequency of 38. Now to find the frequency for the class interval 40 to 60, we have to subtract the cumulative frequency of the class interval 20 to 40 from the cumulative frequency of the class interval 60 to 80. So here we have the cumulative frequency of 102 for the class interval 40 to 60. So we will take away 80 from 102 and we will get 22 as a frequency. Now we have to find out the frequency for the class interval 60 to 80. We have to subtract the cumulative frequency of the previous interval 40 to 60 from the cumulative frequency of the class interval 80 to 110. So for 60 to 80 class interval, we have a cumulative frequency of 122. So we will take away 102 from 122, and we will get 20. Now the frequency for the class interval 80 to 110, we have to subtract the cumulative frequency of the previous class interval 60 to 80. So from the cumulative frequency of the class interval 80 to 110, so class interval 80 to 110 have a cumulative frequency of 88, of 188. And we subtract 122 from 188. And we will get 66 as a frequency. Now for the last class interval 110 to 120, we have to subtract the cumulative frequency 80 to 110 from the cumulative frequency of the class interval 110 to 120. We have cumulative frequency of 200 for the class interval 110 to 120. For 80 to 110, we have a cumulative frequency of 188, so we have to subtract 188 from 200. And we will get the frequency equals to 12. So this is the complete frequency table. Now in the part 2, we are drawing a y-axis and x-axis. Along x-axis, we will take annual incomes, here we have 0, 20, 40, 60, 80,
80
100,
and 100.
and 120. So now we have scaled the,
And here we have 120. So here we have scaled the x-axis.
now we will scale the y-axis with the points, and those points are the frequencies. So here we have the points 0, 20, 40, 60, and 80.
To construct a histogram, we have taken annual incomes along x-axis, and on along y-axis we have taken the frequency. So now since we have group our data into the class interval, and here we have the corresponding frequencies in the front of each class interval, and the frequency of the each class interval. Then we have to plot the frequency of each class interval as a bar on the histogram. So for the class interval 0 to 20, we have the frequency of 42. So here we will draw a bar of the height.
42. Now, for the class interval 20 to 40, we have a frequency of 38. So we will draw a bar from the point of 40 and this bar has a height of 38. Now for the class interval 40 to 60, we have a frequency of 22. So we will draw a bar of the height 22 from the point 60. Now for the class interval 60 to 80, we have a frequency of 20, so we will draw a bar of the height 20. Now for the class interval 80 to 110, we have a frequency of 66. So we will draw a bar of the height 66 from the point 100. Now for the last class interval 110 to 120, we have a frequency of 12, so we will draw a bar of the height 12. And hence, this is a histogram for the frequency distribution.
Now for part 3, if a household is selected at random from this district, what is the interval of annual incomes the household is most likely to earn? So we have to find out the interval of annual incomes from the frequency table that the household is most likely to earn. So that interval will be from the table. If we observe from the table which class interval has the highest frequency. So here we have the 1, 2, 3, 4. 66 is the highest frequency in the table, and the corresponding class interval for the frequency of 66 is 80 to 110. So for the class interval 80 to 110, the annual incomes of the household is most likely to earn. Now, if two households in the part 4, if two households are selected at random from this district, find the relative frequency that the annual income of the households will be at least $20,000 but less than $60,000. So, to find out the relative frequency of the incomes between $20,000 and $60,000, first we have to identify the frequencies between the $20,000 and $60,000.
So here we have two intervals in the frequency table. The first one is 20 to 40 with a frequency of 38, and the second class interval is from 40 to 60 with the frequency of 22. So now to find the relative frequency between $20,000 and $60,000, the total frequency for this range is equal to 38 plus 22, and it will give us 60. Now we have to find out the relative frequency for the two houses selected at random from the district. So for the relative frequency, we have the formula number of occurrences divided by total number of trials. So here we have the number of occurrences 60 and the total number of trials is 200. And since we have already selected one house, so total number of households that are left is 199, and the number of occurrences for the second household to be selected will be 59, just because we have already selected one household. Now we can make further simplifications. So with the help of table 2, we will have 230s is 60 and 200s 2 times 100 is 200, 215s is 30 and 2 fifths is 50 is 100. Now with the table of 5, we have 5 threes are 15 and 5 tens are 50. Now 3 multiplied by 59 is equals to 177, and 10 multiplied by 199 gives us 1990. So the relative frequency that the annual income of the households will be between the $20,000 and $60,000 is equals to 177 over 1990.
Now in the question 8, the table below shows the ages of the 80 workers in a company. So here in the first column we have the ages and X years, and in the second column we have the number of workers. So in the part 1, copy and complete the following cumulative frequency table for the given data. So let's have a look on a frequency table. This one is about ages of the 80 workers work in a company. So for cumulative frequency table, first entry will always be the same as the frequency table. So if we have a look on the first entry, we can see it's from 20 to 25 with a frequency of 9. So we will copy it as it is into the cumulative frequency table as well. Like X less than 25 years with the frequency of 9. Since the frequency for the second entry is already given, cumulative frequency for the second entry is already given in the question, and that is 10. So we will begin with the third entry. Okay, but here there are changes in the case of cumulative frequency table. Since we are going to look since we are considering the cumulative frequencies, So if we look at the third entry, 30 to 45 with a frequency of 6, since this is cumulative frequency, so we have to include all the previous frequencies as well, i.e. we have to include the ages of all of the workers of the first group and also the ages of the all of the workers of the second group as well. So we have to add the new frequency of 6 into the previous total. So 10 plus 6 gives us 6 cumulative frequency of 16. Now we need the ages of the workers goes from 20 to 35 as well. Ages of the workers goes from 20 to 35 as well. Now for the fourth entry in the frequency table, with we have the class interval of 30 to 40 with a frequency of 24. So we have to include all the previous frequencies as well. So we will add the new frequency of 24 into the previous total, and that was 16. So 16 plus 24 will gives us 40. Now if we move to the next entry in the frequency table, the class interval 40 to 45 with the frequency of 21, we have to include the ages of all the workers from 20 to 45, and so 40 plus 21 gives us the cumulative frequency of 61. Now if we look at the next entry in the frequency table, the class interval 45 to 50 with the frequency of 12, we need the ages of all the workers goes from 20 to all the way up to 50, and we will add this new frequency of 12 into the previous total. So 61 plus 12 gives us the cumulative frequency of 73. Now if we look at the last entry of the frequency table, the class interval goes from 50 to 55 with a frequency of 7. We have to include all the previous frequencies, and we need the workers of all the ages goes from 20 up to all the way up to 55. So we will add this new frequency of 7 into the previous total. So 73 plus 7 will gives us 80. It will give us the cumulative frequency of 80. So this is the completed cumulative frequency table. Now in the part 2, using a scale of 1 centimeter to represent 5 years on the horizontal axis and 1 centimeter to represent 10 workers on the vertical axis, draw a cumulative frequency curve for the given data. So
Here we will draw a y-axis and x-axis. We call it the vertical axis and the horizontal axis respectively.
along x-axis we have age in x years, And along y-axis, we will take cumulative frequency. Now we scale the points on the x-axis. So here we have
Now we have 20, 25, 30, 35, 40, 45, 50, 55. And we have the last point, 60. Now along y-axis we have the points 0, 10, 20, 30, 40, 50, 60, 70, 80, and the last point is 90.
Now we will use the cumulative frequency table to draw the cumulative frequency curve. So now it is given in the question that 1 centimeter represents the 5 years on the horizontal axis. So it means one box represents the 5 years on the horizontal axis, and 1 centimeter represents the 10 workers on the vertical axis. So for x less than 25, we have the for x less than 25, x less than 20, we have the frequency 0. So here we will put a cross. For x less than 25, we have the frequency, cumulative frequency of 9. So here we will put the cross x below the 10. For x less than 30, we have the cumulative frequency 16. So here we have something somewhere here. We will put the x. For x less than 30, we have the frequency 10. For x less than 35, we have the cumulative frequency 16. For x less than 40, we have the cumulative frequency of 40. For less than 45, we have the cumulative frequency of 61. For x less than 50, we have a cumulative frequency of 73. And for x less than 55, we have a cumulative frequency of 80. Now we will connect these crosses with a smooth curve. So this is the cumulative frequency curve. In the part 3a, using the curve in the part 2, estimate the number of workers who are younger than 33 years old. So on the x-axis, we have to identify the point 33. We have 33 somewhere here. And now we will draw a vertical line from the horizontal axis until it cuts the curve. Now from the point of intersection on the curve, we will draw a horizontal line until it touches the vertical axis. So here we have the reading of 10, 11 and 12. So here we have a reading of 12. So from the curve, the number of workers who are younger than 33 years old is equals to 12. Now in the part 2b, we have to estimate the fraction of the workers who are at least younger than 46 years old. But for this, first we have to find out the number of workers who are younger than 46 years old. So from the curve we have 46 somewhere like here. So from 46, from on the horizontal axis, we will draw a vertical line until it touches or it intersects the curve. Now from the point of intersection on the curve, we will draw a horizontal line until it touches the vertical axis. So here we have 60, 62 and 64. So from the curve, the number of workers who are younger than 46 years old is equals to 46. Since we have find out the number of workers who are younger than 46 years old, so we can easily find out the number of workers who are young, number of workers who are at least 46 years old. by subtracting the number of workers who are younger than 46 years old from the total number of workers, and that was 80. So 80 minus 64 will be equals to 16. So now we have to find out the fraction of workers who are at least 46 years old. So now we have to find out the fraction of workers who are at least 46 years old is equals to the number of workers who are at least 46 years old is 16 and the total number of workers is 80. And after simplification, it will give us 1 over 5. So the fraction of the workers who are at least 46 years old is equals to 1 over 5. Part 3C, we have to estimate the value of P if 75% of the workers are at least P years old. First, we have to find out what is meant by the 75% of workers. Is equals to 75 over 100 multiplied by the total number of workers, and that is 80. And after simplification, we will get 2 4s are 10, 2 5s are 10. And with the table of 5, we can further simplify it. And we have a 5, 1's a 5, and 5 5's a 25. So 15 multiplied by 4 is equals to 60. So 75% of workers is equals to 60 workers are at least P years old. Since we have find out the number of workers that are at least P years old, but we have to find out the number of workers that are less than P years old, just because there is no information given about the number of workers who are at least P years old in the question. So here we will subtract the number of workers who are at least P year old from the total number of workers. So we will get 20 workers are less than P years old. Now from the curve, since we have find out the number of workers and that is 20, so here we will reverse the things. Here we will draw a horizontal line from the vertical axis until it intersects the curve, and from the point of intersection we will draw a vertical line until it touches the horizontal axis. So from the curve we have get the reading 36. So from the curve, the value of P is equals to 36. The part 4. If two workers are chosen at random from the 80 workers, find the probability that the workers are younger than 38 years old. So first we have to find out the number of workers younger than 38 years old from the curve. So here we have 38 somewhere here. And we will draw a vertical line until it intersects the curve. Now from the point of intersection on the curve, we will draw a horizontal line until it touches the vertical axis. So here we have get the reading of 30. So the number of workers younger than 38 years old from the curve is equals to 30. Now we have to find out the probability of workers are younger than 38 years. Thirty-eight years old. So here we have the number of favorable outcomes in this case is 30 divided by total number of outcomes is 80. Since we have to select two workers at random, so if we selected one worker, then the total number of workers are left will be 79. And since we have already selected one worker from the 80 workers, so we are left with 79. And since we have already selected one worker that are younger than 38 years old, so the workers that are younger than 38 years old left are 29. Now after simplifications we will get, now we have 29 multiplied by 5. We have 215s are 30 and 240s are 80. Now we have further simplifications. 5 3s are 15 and 5 8s are 40. Now 29 multiplied by 3 is 9 3s are 27 and 3 to the 6 and 87. So in the numerator we have 87 divided by, and in the denominator we have 632. So the probability that workers are younger than 38 years old is equals to 87 over 632.